It's on.
It's on.
Trying to
It's
turn it
on.
off. I don't think anyone has any problem hearing this voice in this room. We're okay? All right. Thank you for having us here today. As Steve said, I'm Eric Sadler, engineer with Snake Tray Cable Management Solutions. About a year ago, we did some research to try to define and identify all the things in the National Electrical Code as they pertain to cable pathways. We put together this presentation for your information. I try not to keep it too dry. We're going to try to have a good time with it, so please enjoy it. If you have any questions throughout the presentation, please feel free to just identify yourself, raise your hand, shout out, and we'll stop and answer your question. All right then. Kind enough to get this nice little wonk. Let's see how well it works. So, cable pathway use and selection of the National Electrical Code by yours truly.
Let's try it.
Who owns this thing? What am I doing wrong? Worked 30 seconds ago. What am I doing? Like that? Okay. For reference purposes, this presentation was based on the 2011 code and its handbook, so all the references and sections of the code, that's where we lifted it. Okay, terms that we think of in real everyday life as opposed to what the code calls things. So before we go on, let's identify a few terms we'll use throughout the presentation, particularly as they pertain to pathways. So we think of power, the code calls it conductors for general wiring, governed principally by Article 310. We call it premise data, the code calls it Class 2 and Class 3 circuits, and principally governed by Article 725. We think of utility and service provider data. That's what the code calls communication circuits, and that's principally governed by Article 800. Okay, what pathways will we discuss? Try to get all of them that are addressed by the code and that you'll use in your everyday design and installation life, including raceways, conduits, tubing, and the like. Metal wireways, what we would call troughs. My personal favorite, cable tray. And my other personal favorite, devices to hang cables directly from building structure, hooks, and continuous cable routing assemblies. In the 2014 code, they actually, I'm using the term continuous cable routing assemblies because it was added to 2014, and I'd like people to get used to seeing it. Basically, it's a continuous series of hooks, and they call it a cable routing assembly. Okay, our goals in the hour we have together. We'll identify a few important rules, discuss the spirit of those rules, dispel a few common myths as they pertain to cable pathways. Let's talk about the spirit of the National Electrical Code. In the beginning, there were 10 laws. And there they are, the original 10. I worked with an engineer when I first graduated, and this is basically his idea that he planted in my head 20-some odd years ago, is what the rest of the presentation is based on. He said in the beginning there were 10 laws, and that was 8 too many. Because all laws can be boiled down to 2. Do not hurt anyone, and do not touch their stuff. To enforce these laws, we used to have the feudal system. A kindly lord would hear each individual case and determine if someone hurt someone or touched their stuff, and dole out a sentence. The kindly lord, circa 1100 AD. However, the decisions of the kindly lord were pretty arbitrary, both literally and figuratively, so we decided we were going to enact precise laws to tell us what we can and cannot do. Fast forward 1,000 years or so, and we now have the National Electrical Code and its handbook, a 1,500+ page document to essentially tell us do not hurt anyone, do not touch their stuff with electricity. And there it is. There's the statement, the purpose of the code. Practical safeguarding of persons and property from hazards arising from the use of electricity. Don't hurt anyone, don't touch their stuff with electricity. And even with the 1,500 plus pages, we still need the kindly Lord, the AHJ, who has the right to interpret the code however he or she sees fit. So the AHJ, we can do our best, we can discuss this, I can tell you what I think, you can tell me what you think, but in the end, what he says goes. Okay, the NEC is written to protect people and property from the hazards of electricity. Let's categorize these hazards: fire, electrocution, and physical hazards. So let's talk first about fire. Part of fire prevention is to prevent the spread of fire and products of combustion. And there it is in the code. We shall not, see, go back to this slide more carefully. Two things in this slide. Basically, this is the section of the code that calls for fire stop for fire-rated walls. But it also makes a statement almost, I will say casually, that you will not use wiring to increase the spread of fire from one wall to another. And the AHJ that I have spoken with have said, basically that means the wall was made of tissue paper and it had 2 seconds of fire rating, and you poked a hole in it so that it now only had 1 second of fire rating. You got to fix that hole to restore the 2 seconds of fire rating back. That's what this section of the code is, those two things: fire stop and restoring walls before you put the wiring in, as to the way they were before you put the wiring in. So don't let the fire spread. Mention again fire stop. And in no case shall wiring substantially increase the spread of fire in the product of combustion. So those are the two pieces of fire spread from that section of the code as they pertain to pathways. And here we see cable tray penetrating, actually a continuous cable routing assembly, and that's a fire stop as you use it in Central America. Okay, don't let the smoke spread either. Section 300.22, it redefines plenum in 2011 as other spaces for environmental air, as opposed to spaces for environmental air. Thinking, well, I'm going to put this wiring in a ventilation duct. That's not really what plenum is about. It's the other spaces that happen to handle environmental air. So I would say discouraging, but not addressing wiring in areas whose sole purpose is air distribution. Requires wiring methods in plenum spaces to be totally enclosed. That's what this section of the code says. Examples of totally enclosed would be conduit, MC cables. It specifically allows cable tray to support those other enclosed methods, and further qualifies cable trays with solid tops, bottom sides as completely enclosed wiring methods. So that's a perfectly acceptable pathway for this section of code when you need to retain your plenum rating. Here's a good picture of enclosed wiring methods supported by tray. Of course, better still, prevent the fire from starting in the first place. And we do this two ways. NEC 1310-15A3 do not allow heat to build up to temperature that would ignite cables or surrounding materials. And 254A1, dissipate your shorts to ground. So these two things together will prevent fire from starting in the first place. And of course, grounding not only prevents fire, but also risk from electrocution, the other form of hazard. Okay, when it talks about temperature in conductors, this is defining it, saying you will not wire anything such that the temperature will heat up the wires and risk a fire. And ground it. And it even mentions against lightning, line surges, unintentional contact with higher voltage, stabilized to earth during normal operation. Heat is generated by the current. And safe currents for every common cable are well documented in the NEC. So that's what we think about when thinking about power in cables. Make sure we have the safe current under the operating conditions. The baseline currents on which different things are based are in a set of tables in 310.15b, tables 16 through 21. We'll quickly go through what those tables contain. So each table operating conditions are as follows. So number 16 is for 1 to 3 insulated conductors up to 2,000 volts. Cables rated between 60 and 90 degrees in earth, raceway, cable jacket, or conduit. That's a pretty common one. That's a pretty common way things are wired. You got a few conductors, you're putting them in a conduit, or you're burying them in a trough in the earth. The second most common would be single insulated conductors in the same temperature range in free air. And the other tables we'll go back to, but these are the two most important ones. So here we have 18 is 1 to 3 insulated conductors based on a much higher temperature. These are kind of obscure cables that are rated at a higher temperature in 40 degree, based on 40 degree ambient, again in earth, raceway, cable jacket, conduit. The other one is the same thing based in free air. 20 is a modest temperature range on a messenger wire. And the last one is your transmission lines, bare or covered conductors based on 80 degrees centigrade in free air with a slow wind blowing over them. I don't imagine that's probably part of much of your design unless you're a power transmission designer, which you might be. But of those tables, as I mentioned, the first two are referenced most often and used most commonly in commercial applications. And here they are. And for those of you who do any kind of electrical design, you can see you'll recognize the cables that come up all the time. You see THHN, THWN, USB2, USB, plain USB. These are all your basic cables used in commercial and industrial wiring. And this is, again, in conduit, earth, or jacket. And then the other one is the same cables based in free air. So you choose the table based upon your operating conditions, and then the percentage of baseline current, so there'll be a correction factor, will be temperature dependent and pathway dependent. And that's one of the reasons I'm bringing this up, because we want to talk about pathways in the code, and your pathway will determine the correction factor you use based on those tables. Is that clear? Pretty much? So the temperature correction factors have their own table. If it's cold, you get a little more. If it's hot, you get less. Remember, those two tables were based on 30 degrees centigrade or Celsius, excuse me, and the other one was based on 40 degrees. So there's two tables that give you your temperature correction factor, and you can see it varies. Ambient temperature, when it's real cold, you get a multiplier that actually helps you out. You put more current, and as it gets hotter, you can use less and less. Same thing for the 40 degree rated cables. For single conductors in a raceway or in the jacket of a cable, there's a table that gives adjustment factors to the table based on the ones in a jacket. So you have these factors are determined by the number of cables in the jacket or raceway. Most people have seen this table before. It's pretty common. You're thinking about stuffing cables in a conduit. If you have this number of cables, then you get that correction factor. And it's based on simple physics, right? The larger the number, or the higher the number of conductors, the more physical area in the conduit you're going to take up and the less airspace. So the less airspace, then the higher the correction factor you need to use. For multi-conductor cables in cable tray, you use that very same chart. You adjust for the cable, not for the tray. So there's no additional correction factor for taking your multi-conductor cable in a jacket and sticking that in a tray. Use that same chart. Except where there is 6 feet or more of cover on the tray, the code refers you to apply an additional correction factor of 0.95. .392 is the section of code that governs tray, and this particular section governs cabled together, bunched together in a cable tray for single conductors. There's a 0.75 correction factor applied to the free air table for cables that are pretty large in diameter, 600 kilocircular mils or larger. And then there's a 0.65 correction factor for 1/0 through 500. So this is single conductors in a tray. There is a special provision in Article 690, which is the solar section, photovoltaic circuit section of the code, that permits single conductors of cables less than 1/0 in size in exposed wiring methods such as tray. However, the NEC has not caught up to this. There's not a table that says, oh, when you want to put your cables in a tray like we said you could in the solar array section, this is the table you use, or this is the correction factor you use. So we as designers are on our own to estimate or calculate what the correction factor should be. And what I've done in past for customers is said, okay, what do you need to do? And then let's look at what it would be in a raceway, because you know you're going to have much better air circulation in a tray than you would in a raceway or jacket. So if you have a safe current as it would have been in a conduit, it's even more safe when you apply that same current in a tray. That's one way you might estimate what's safe in this particular scenario. Okay, as many of you are low voltage designers, we want to spend some time on low voltage. Class 2 and 3 in communication circuits do not carry sufficient current to cause a fire or power to cause electrocution, but that did not stop the code writers from writing an entire section to cover their use and installation. It does mean that there are fewer and less strict regulations than there would be for power, than there are for power circuits. As per NEC 725-24, Class 2 and 3 circuits can be attached directly to building structure. It actually spells that out. You can attach it to building structure, your Class 2 and 3 circuits. And this is usually accomplished with devices listed for that purpose. UL 2239, hardware for the support of conduit tubing and cable. That's how you can safely and in a way that every inspector will smile at, attach your Class 2 and 3 circuits to building structure. There are various hooks and continuous cable routing assemblies that are listed this way. There's a hook, cable routing assembly attached to building structure. Okay, let's get to the myths. Myth number 1. If you choose to put your cables in a cable tray, you must use a tray that is UL listed. Fact. Repeat after me. There is no such thing as UL listed cable tray. There is no such thing as UL listed cable tray. Thank you. As per NEC 39260B, tray can be UL classified as an equipment grounding conductor, EGC, if it is identified as an EGC, the cross-sectional area of the conducting members of the tray meet the requirements of Table 39260A, greater than 0.2 inches squared in total cross-section. That area is marked on the tray for trays of channel or one-piece construction, and sections are connected according with the grounding section 25096 using bolted connectors or bonding junction. So this UL classification that we all seek is a very sophisticated test. They come to your factory with a set of calipers and they measure the diameter of the tray sections that are going to be connected, and if the sum of the sections that are going to be connected exceed 0.2 inches, you're UL classified.